So coming to the demo on inline assembly, let us copy the same code that we had for pointer arithmetic and put it in here, and then save the file and edit the make file like we did. So the make file, in the make file we'll have to put inline assembly.c here. So we save it. So this is what we have here in the make file now. So inline assembly, this one is going to be compiled now, and this is the same file that we saw in main, but we are going to again, so we are going to remove all of this, okay, and we will be working on putting the inline assembly code here. So we'll take it directly from the presentation. Okay. So the first inline assembly that we shall see is ASM move R010, this one. Okay, so let's copy and paste it here. And let's compile this code. So let's save it and let's compile it and put it on debug at the same time. So it is on debug now. Okay. Now what we do is we step through. Now here, when we step through, we are going to look into the general registers, because that is where the changes are going to happen, right? So we are in the general registers tab here. So this is the PLL in it. So, and then we see ASM, it is move R0 to. So whatever PLL init did here, it actually changed these registers. So that is why you see these are highlighted now. So let's not worry about that. Our concern is R0. So let's move 10 to R0 and see if it has really moved it or not. As you can see, 10 has been moved to R0. R0 is 0xa. Okay. So that means we have successfully been able to write an inline assembly code where we could directly write into a particular register. Let's see the second one. Second one is, so it is move R010, move R120, R2, add R2, R0 and R1 and put it in R2, and then move R0 to R0. So this one, let us see what it does. So we'll replace that one with this, and let us see if it, because since we are not putting the volatile keyword here like we said we would, let's put it below here. Yeah. So let's put it on debug and see what happens. So it will not single step line by line through here. It will just jump across the assembly and come to return, because it will all do it together. See, it will not single step here. Let's see. So we are here. All of this has changed. So R0 will have 10, R1 will have 20, R2 will have the addition of R0 and R1, and then this is move R0, R0. So let's step. As you saw, it executes all these instructions, but it doesn't step through within the assembly. If you had separate ASM statements, then it would do that. So R0 is 10, R1 is 14 is 20, 6 in hex 14 is 20, R2 is 10 plus 20 equal to 30. 30 is 16, 1 is 16 plus 14. Okay. So 1 is, if you have a doubt, just number format, decimal, it is 30. Okay. So we add it, and then R0, it's just A, it doesn't do much. So we wrote a complete inline assembly code where we assigned two values to R0 and R1 and then added those two registers, put that value into R2. This statement doesn't do much. Now let us do this one, that is the inline assembly with the general in its general form. Okay. So let's copy this completely, copy and replace this. So this is inline assembly in its general form. So what it does is there are some values that are already declared here, and we are going to see that these variables are getting manipulated, but there is no control over which register we are going to use. It's just, it can use anywhere between R0 to R15. So let's try to compile this. Let's hope it compiles. So it compiled peacefully. Now it will put it on debug. Single step. So these registers values have changed. We'll not bother about it. Okay. Now these values are getting assigned, variable 1 inline, variable 2 inline. So if you see the variable values, variable 1 inline and variable 2 inline has got assigned to 10, and then this is going to get assigned to 20. Okay. Now, and variable 3, the addition we are doing through inline assembly. We are not doing it through the standard variable 1 plus variable 2 method, that is through C. So let's go into the registers, and here we don't have a clue as to which registers are going to be used. Okay. So let's step. So when we step, we see that 10 and 20, these two registers have been used, that is R2 and R3. Okay, so probably it actually reused one register to do the addition, so we see only two registers being affected. Okay. So this is how it is done. So R3 actually has the output, that is 1E, that is 30. R2 has 20, and we don't know, probably R2 only, R3 only contained 10, and then 10 and 20 was added. So it would have been add R3 and R2 R3. Okay, so but what would happen in that case is the R3 is old value of R3 is going to be overwritten with the new value. So we'll try that out as well to be 100% sure. So we know that. Let's check the value 3 now. So value 3 is 20. So did you see probably when the C code writes assembly for this, when you do a actual in C, when you do variable 2 inline plus variable 1 inline, actually in the backend it might be writing assembly, some assembly like this only, but here we wrote the assembly explicitly, and we forced the compiler to take this up. Okay. So yeah, we didn't put volatile, but if you put volatile, this is going to be sure shot executed. Now let us check. So we said that we have to we'll double check if what we assumed was right, that is only two registers were used for this calculation. So let's do that. So let's delete this, stop the debug, and take this one only, the previous one, and instead of say move R0 10, R0 R2 20, so R0 R1 and R2, so what we'll do is move R1 R0 R1. We'll do that. Okay, so when we do move R1 R0 R1, means that, and let's delete this. Let's delete this. We don't need this. So what happens is it takes these two values, it adds these two values first, and then puts it back in R1. So it is using one register less, and that's what we saw. So let's try this out and see what happens. And we'll keep an eye on the registers, since this is not a general form. We are not writing anything in any variable. So register view, and then step. Okay. So as you can see, R1 has been overwritten. Okay. R0 and R1 are the two registers that have been used only. You see this is A. R1 was put to a value of 20 was put on R1, but then once the addition was done, R1 was overwritten. And that is why when we did this, when we saw the general form, even though there were three values, we only saw two registers, R2, R3 being used. So that was the reason we didn't see three registers. So that is how that is because of how the assembly code was written by the compiler in the backend. So this is a quick tour of how inline assembly works. At least whatever we have done on inline assembly here will be more than enough for our course. But inline assembly in itself is a big topic, and if you want to learn more about it, there are a lot of resources on the internet. But for us, this is enough.